Hey boys and girls, this is Miss Bada. We are beginning chapter 13, which is on heat and heat technology. Starts on page 378 and 379. Section 1 is on temperature, and this starts on page 380. First, we need to define temperature. Temperature is a measure of how hot or cold something is, specifically a measure of the average kinetic energy of the particles that are in an object. Now, this goes back to what we have previously learned about kinetic energy, which is all about motion. All matter is made up of two things, atoms or molecules. Now, these atoms and molecules are always moving, even if it doesn't look like they're moving, especially in solids. And the faster the particles are moving, the more kinetic energy that they have. So the more kinetic energy the particles of an object have, the higher the temperature of that object. So all objects are going to have kinetic energy because they have a temperature. Even though they may not look like they're moving, they are. Next, we have defined absolute zero. Absolute zero is the temperature at which molecular energy is at a minimum, or at which we say motion is stopped. Now, we, as sixth graders, do not have to worry about trying to reach absolute zero. This has to be done in a very sophisticated lab. So is it possible to actually reach absolute zero? The answer, of course, is going to be no. Okay? We will be watching some videos. I believe it's on Brain Pop, where it talks about it's very hard to reach absolute zero. Sometimes out in deep, deep space, you might be able to reach absolute zero, but then again, you have a lot of cosmic background radiation, which causes movement. All right, moving on to page 382, measuring temperature. You will see on page 382 in your book, as well as on your paper here, 3 temperature scales. We have Fahrenheit, Celsius, and Kelvin. Kelvin is used in laboratories, and this is what is used to get down to that absolute zero. We need to be familiar with Fahrenheit and with Celsius. Now, most of us realize or know that on Fahrenheit, 32 degrees is the freezing point. 98.6 is our body temperature, and 212 degrees Fahrenheit is the boiling point. Now, we're less familiar with Celsius. We're the only country that still uses Fahrenheit, but you need to memorize these important Celsius temperatures. 0 degrees Celsius is freezing point. That would be equal to our 32 degrees Fahrenheit. 37 degrees Celsius is the same as 98.6 degrees Fahrenheit, which is our body temperature. And then 100 degrees Celsius is the boiling point. The Celsius is based on 10. And if we had learned this, or if you had learned this from when you started kindergarten on, it would probably be much simpler. And I've put on here that Kelvin is what is used in labs. All right, so I'm telling you to get your calculators so we can convert some of these Celsius to Fahrenheit and then Fahrenheit to Celsius, okay? So we're going to do 10 degrees Celsius times 1.8 plus 32. Now, you know the first thing you have to do is put your parentheses around 10 times 1.8 And when you multiply that, that will give you, it will actually give you 180, but then you move your decimal back to the left, so you have 18. Then you add plus 32, and that will give you what? If you said 50 degrees Fahrenheit, you would be correct. For converting Fahrenheit to Celsius, we're going to use 50 degrees Fahrenheit. Now, some of you should have already figured out what our answer is going to be without doing this, but we're going to work through the problem anyway. So 50 degrees Fahrenheit minus 32 divided by 1.8. So I put my parentheses around 50 minus 32, and that's going to give us 18. Then divided by 1.8 will give us 10 degrees Celsius. So if you look at what I did, this is the exact opposite. All right, thermal expansion is an increase in the size of a substance in response to the increase in the temperature of the substance. Now, I'll let you get that copy down first before I go on. Basically, what thermal expansion means, the hotter something gets, the increase in temperature, the more it's going to move around, and the more space those particles are going to take up. Like, for instance, my hands and feet will swell during the summer when it gets really hot. That's because I'm moving around, doing stuff. My body temperature probably doesn't increase, but my molecules are moving more, and so everything expands. You see down in the pictures underneath here, the first picture is of an expansion joint. These, I know that you can see or hear these on the bypass when you go across a bridge, maybe over the Asheville Highway when you go across the bridge right there at the waterfall, at the dam, sorry. Also shows a hot air balloon. What kind of expansion is taking place in that hot air balloon? Then you also see a bimetallic strip. Now, this is in an older type of thermostat, and you can't see the picture very good on your paper, but you can look in your book on page 384, and it shows you a beautiful picture there of when we say bimetallic strip, that means two different types of metal are put together, and because each responds differently to heat, it will coil or uncoil, and that's what causes your thermostat to go on or to go off. So we'll finish with heat a little bit later.